Good morning, students. Now we are going to start the other questions of exercise 11.3 three-dimensional geometry. Find the angle between the planes whose vector equations are r vector dot 2y plus 2j minus 3k equals to 5 and r vector dot 3i minus 3j plus 5k equals to 3. As we know that the vector equation of a plane is given by r vector dot n1 equals to q, r dot n2 vector equals to p. So here n1 is our 2i plus 2j minus 3k, n2 is our 3i minus 3j plus 5k, and angle between the two planes is given by the formula cos theta equals to modulus of n1 dot n2 upon modulus of n1 modulus of n2. So we find out the scalar product of these two n1 and n2 vectors and the modulus of n1 and n2. We simplify and at last we get the angle cos inverse 15 upon under root 731. Next question, 13th question. In the following cases, determine whether the given planes are parallel or perpendicular, and in case they are neither, if they are not perpendicular and not parallel, you have to find out the angle between them. So the given planes are 7x plus 5y plus 6z plus 30 equal to 0, and second is 3x minus y minus 10z plus 4 equals to 0. So a1 is 7, b1 is 5, c1 is 6, a2 is 3, b2 is minus y, c2 is minus 10. For the condition of perpendicularity, if you want to check, we have to check a1, a2 plus b1, b2 plus c1, c2. When we solve it, it gets us minus 44, which is not equals to 0. Therefore, plane 1 is not perpendicular to plane 2. And now we check for the condition of parallelism of the planes. Condition for parallelism of the plane is a1 by a2 must be equal to b1 by b2 equal to c1 by c2. So we are first checking a1 by a2, that is 7 upon 3, b1 by b2 5 upon minus 1, c1 by c2 6 upon minus 10, we converted the standard form, minus 3 by 5. As we can see that 7 by 3 is not equal to 5 by minus 1 is not equal to minus 3 by 5. So all these three ratios are not equal to each other, hence the plane 1 is not parallel to plane 2. So here both the given planes are neither perpendicular nor parallel. So we have to find out the angle between these two planes. Cos theta equals to a1 a2 plus b1 b2 plus c1 c2 upon under root over a1 square plus b1 square plus c1 square into under root over a2 square plus b2 square plus c2 square. On substituting the values of a1 b1 c1 a2 b2 c2, at last on the simplification, angle theta equals to cos inverse of 2 by 5. Now the next question is that you have to find out the distance of a point from the given plane. The given plane is 2x minus y plus 2z plus 3 equal to 0. This is the question number 14 b1. The distance from a point 3 minus 2 1 on the plane. It is given by the formula ax1 plus by1 plus cz1 plus d, that is the equation of the plane, and the point x1 y1 z1 is here 3 minus 2 1 upon root over a square plus b square plus c square. So 2 into 3, x1 is 3, 2 into 3 minus y is minus 2, z is 1, 2 into 1 plus 3, that is d, upon root over 2 square 4 minus 1 square 1, 2 square 4. After simplification, we are getting the perpendicular distance as 13 by 3 units. Okay. Now let's come to the question number 10, 11 and 12. They are the most important questions. Question number 10 I am going to solve, and you have to solve question number 11 and 12. The equation of a line passing through the point x1 y1 z1 5 1 6 and x2 y2 z2 3 4 1. So the equation of a line passing through the 2 points x1 y1 z1 and x2 y2 z2 is given by x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. So x minus 5 upon 3 minus 5, y minus 1 upon 4 minus 1, z minus 6 upon 1 minus 6. So x minus 5 upon minus 2, y minus 1 upon 3, z minus 6 upon minus 5. We get the equation of a plane in the Cartesian form, in the symmetric form. It crosses yz plane, but in yz plane the value of x is 0. So here we will going to put it as x value as 0. So 0 minus 5 will be minus 5 and upon minus 2, y minus 1 upon 3 equal to z minus 6 upon minus 5. Now this first ratio we are getting as a constant. To get the value of y and z, we will take for y these two ratios and we will get the value for y. And for getting the value of z, we will take the first and the last term and we get the value of z. And x is already, it is 0. So the coordinates of the point will be x, y, z 0, 17 by 2 and minus 13 by 2. Okay. The question number 13. Find the equation of the plane passing through the point minus 1, 3, 2 and perpendicular to each of the planes x plus 2y plus 3z equal to 5 and 3x plus 3y plus z equals to 0. So the equation of a plane passing through a point, one point, x1, y1, z1 is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1. जैसे कि यहाँ x1, y1, z1 पॉइंट दिया है क्वेश्चन में -1, 3, 2, we replace it a into x plus 1 plus b into y minus 3 plus c into z minus 2 equal to 0, and the direction ratios of this plane is a, b and c. And plane 1 is now perpendicular to the two given planes x plus 2y plus 3z equals to 5, whose direction ratios are coefficient of x, y and z, that is 1, 2 and 3. And the second plane is 3x plus 3y plus z equal to 0, and its direction ratios is 3, 3 and 1. So now, since the plane 1 is perpendicular to plane 2, so as we know the condition for perpendicularity of the plane is a1, a2 plus b1, b2 plus c1, c2 is equals to 0. So 1 into a, 2 into b, 3 into c will be equal to 0. So we get a linear equation in 3 variables, a plus 2b plus 3c equal to 0. And the second plane 3 into a, 3 into b plus 1 into c. So we get the second one equation 3a plus 3b plus 3c equals to 0. Now we are going to solve by cross multiplication method as we are solving in class 10. For solving a, from the top of the b, 2 into 1 minus 3 into 3, 9. Top to bottom minus bottom to top. Next for b, we will start from the top of c. a के लिए b से स्टार्ट करेंगे, b के लिए c के टॉप से स्टार्ट करेंगे, c के लिए a के टॉप से स्टार्ट करेंगे. So for b, 3 into 3, 9 minus 1 into 1, 9 minus 1. For c, we start from the top a 1 into 3, 3 minus 3 into 2 minus 6 here. So we get the value of a as minus 7k, 8k, minus 3k. This value of a, b and c we are going to substitute in equation number 1, equation of plane. So value of a is minus 7k. So minus 7k into x plus 1. Value of b is 8k into y minus 3. Value of c is minus 3k. So minus 3k into z minus 2. Divide all the terms with k. So we will get k will be removed here from here. And now minus 7x minus 7, 8y minus 24 minus 3z plus 6 and simplify it. You will get at last the equation of a plane 7x minus 8y plus 3z plus 25 equals to 0. Okay. Now the last question, that is the question number 21. It is also the most important question. Prove that if a plane has the intercepts a, b and c, with their x-axis, y-axis and z-axis respectively, and is at a distance of p unit from the origin, then 1 by a square plus 1 by b square plus 1 by c square equal to 1 by p square. So equation of a plane with intercepts a, b and c is given by x by a plus y by b plus z by c equals to 1 in intercept form, and the distance from origin x, y, z will be 0, 0, 0 to a plane 1 is equals to p units, which is given as the formula is ax1 plus by1 plus cz1 plus d upon root over a square plus b square plus c square. So 0 upon a, 0 upon b, 0 upon c, as the distance is measured from the origin, and transpose it -1, take the modulus, root over coefficient of x is 1 by a square, coefficient of y 1 by b square, coefficient of z it is 1 by c, so 1 by c square. So after squaring both the sides, at last we will get the result 1 by b square equals to 1 by a square plus 1 by b square plus 1 by c square. This simplification you have to do it, don't write directly. Okay? Now let's start the question number 14. If the points 1, 1p and -3, 0, 1 be equidistant from the plane r vector dot 3i plus 4j minus 12k plus 13 equal to 0, then find the value of p. The equation of the plane is given to us, r vector dot 3i plus 4j minus 12k plus 13 equal to 0, and according to the question, the distance of a point 1, 1p from the plane is equal to the distance from a point -3, 0, 1 to this plane. The distances from these 2 points to a plane are equal. So we applied the perpendicular distance formula, ax1 plus by1 plus cz1 plus d1 root over a square plus b square plus c square. But here it is a vector formula, so passing point is 1, 1p. So I plus j plus pk, second point is -3, 0, 1, -3i plus 0j plus k. So our perpendicular distance formula is here. The distance formula for is here is p is equals to a passing point dot n and plus d upon modulus of n vector. This is our formula, plus d. Okay, whatever the point is here, that we have to take it. So complete vector I plus j plus pk dot 3i plus 4j minus 12k up plus 13, complete plane, equation of this plane, r dot n, a dot n plus d, and this root over 3 square, 4 square, 12 square. Here also -3i 0j plus k dot 3i plus 4j minus 12k plus 13 root over 3 square, 4 square, 12 square. This will be cancelled out. So scalar product, dot product, 3 plus 4 minus 12p plus 13 minus 9, 0 into 4, 0. K into -12 plus 13. After simplification, since it is a modulus, we can take plus minus sign. 20 minus 12p is equal to plus minus 8. When we solve for the positive case, we get the value of p equals to 1, and when we are going to solve for the negative case, we are getting the value of p equal to 7 by 3 units. 4 3s are 12, 4 7s are 28. Now the question number 15 is given that find the equation of the plane passing through the line of intersection of the planes r vector dot I plus j plus k equals to 1 and r vector dot 2i plus 3j minus k plus 4 equals to 0 and parallel to f-axis. Now here it is given the equation of a plane r vector dot I plus j plus k. It is of the form of r vector dot n1 vector equals to d1, and this second one is r vector dot n2 vector equals to d2. So +4 को ट्रांसपोज कर दिया गया है -4. So get d2 is -4. Now the equation of a plane passing through the line of intersection of the plane is given by r vector dot n1 vector plus lambda n2 vector equals to d1 plus lambda d2. So r vector dot n1 vector is I plus j plus k, lambda n2 vector is 2i plus 3j minus k equals to d1 is 1 and lambda and d2 is 4, so it becomes -4 lambda. Now we arrange in the form of ai plus bj plus ck. So I common 1 plus 2 lambda, j common 3 lambda plus 1 and k common 1 minus lambda equal to 1 minus 4 lambda. Now plane 3 is parallel to the x-axis. Where it is parallel to x-axis, the direction ratios of x-axis are 1, 0, 0. And plane is parallel to a line x-axis. So their direction ratios product will be equal to 0. 1 plus 2 lambda into 1, 3 plus lambda into 0, 1 minus lambda into 0 equal to 0. After simplification, we get the value of lambda equals to -1 by 2. This lambda equals to -1 by 2, we have to substitute in equation number 3 here. So I got r vector dot I plus j plus k, as lambda is -1 by 2, so this plus will become -1 by 2, 2y plus 3j minus k equals to 1 plus, as the lambda value is -1 by 2, it will become plus 4 by 2, so 2 and 2 cancel, 1 plus 2 to become equals to here 3. So after taking the LCM, 2y plus 2j plus 2k, opening the bracket, -2y minus 3j plus k, this divided by 2 will be cross multiplied towards the right, 3 into 2 equal to 6. Now it becomes the vector equation of a plane r vector dot minus j plus 3k equal to 6. If we want to convert it in the Cartesian form, then r vector, as we know that we are taking the r vector in the Cartesian form, is xi plus yj plus zk. So xi plus yj plus zk and the dot product with minus j plus 3k equal to 6. So x, no y is there, so it will become 0. Y into -1 minus y, j into 3, that becomes 3, z into 3, 3z equal to 6. So just after transposing, we get the final answer of the equation of the plane in Cartesian form is y minus 3z plus 6 equals to 0. Thank you.